Alright, what's up guys? Let's solve some physics together. So, I got problem 64 from the Halliday textbook. So, let's read it out. So, figure 556 shows a box of mass M2 is equal to 1 kilogram on a frictionless plane inclined at theta is equal to 30 degrees. It is connected by a cord of negligible mass to a box of mass M1 is equal to 3.0 kilograms on a horizontal frictionless plane. The pulley is frictionless and massless. So, this is a two-part question. So, part A. If the magnitude of the horizontal force is 2.2 newtons, what is the tension in the connecting cord, which is this wire? And part B, what is the largest value the magnitude of the force applied may have without the cord becoming slack? So first off, let's tackle our free body diagrams at sigma F statements. So let's start with M1. So M1. So this is my box. M1 is this box in the diagram, and it has a mass of 3 kilograms. And M2 is this block, has a mass of 1.0 kilograms. Alright, so now this box feels a force G from gravity, feels a force up, which is the normal force, from a force left to right, which is our force applied, and a force from this side to the right, which is our force tension, Ft. So now let's start writing out our sigma F statements. So sigma Fy is equal to Fn minus Fg, which is equal to 0, since there's no acceleration in the y direction. Therefore, we know that Fn is equal to Fg. Now, sigma Fx is equal to, so we'll call up and to the right our positive direction. So sigma Fx is equal to Ft plus Fa, which is equal to M1A. So that's our free body diagram and sigma F statement for block number 1. Now let's look at block number 2. So this one is at an angle of 30 degrees. So it feels a force Fg straight down, a normal force perpendicular to the incline it's on, Fn, and then a tension force up the incline. And we'll call down and to the right positive. So here, sigma F, the y direction is equal to Fn minus Fgy. And then that is equal to 0. Therefore, we know Fn is equal to Fgy. And sigma Fx is equal to our I meant to do Fgx minus Ft, which is equal to M2A. So now we'll take this sigma F statement and this sigma F statement and write an acceleration for each block. And since they're in a system, we know that we can set the accelerations equal to each other and solve for the force tension. So let's start with this one. So Ft plus Fa, write that next here. Ft plus Fa is equal to M1A. So we know that the acceleration is equal to Ft plus Fa divided by M1. So now let's take this sigma F statement and write in the equation for the acceleration of the block again. So Fgx minus Ft is equal to M2A. So acceleration is Fgx minus Ft divided by mass 2. So now, since they have the same acceleration, we can set the two equations equal to each other and solve for Ft. So Ft plus F applied is equal to M1, which is equal to Fgx minus Ft all over M2. Okay, now let's cross multiply and solve for Ft. So M2 times Ft plus Fa is equal to M1 times Fgx minus Ft. Sorry if it's a little small. So now let's solve and isolate all the Ft's on the left side. So you get M2Ft plus M1Ft is equal to M1Fgx minus M2Fa. So now we have Ft, M1 plus M2 is equal to M1 Fgx minus M2 Fa. So we know that Ft is equal to M1 Fgx minus M2, force applied, divided by the sum of the two masses. So now let's plug in all our values and solve. So Ft is equal to mass 1, which is 3.0 kilograms, times Fg, so we need to do 1.0 times g times sine 30 minus M2, which is 1, times force applied, which in this case is 2.3 newtons. And I divide all of that by 1 plus 3. So my force total is equal to, plug that in the handy dandy calculator, and you get 3.1 newtons. So that means when the force applied over here on M1 is 2.3 newtons, the tension in the wire is 3.1 newtons. That's part A. Alright, now that we took care of part A, it's time to take care of business with part B. So part B is asking, what is the largest value the magnitude of force applied may have without the cord becoming slack? So basically what that means is, when the cord is slack, there's zero tension in the wire. So we're looking for the value of force applied that would lead to the cord becoming slack. So let me just write that down. When cord is slack, 0 tension. Alright, so from part A we had our final equation, so I'm going to rewrite that. Ft is equal to M1 M2 G sine 30 degrees minus M2 Fa, all divided by the sum of the two masses. So now, like I said, there's zero tension, so I can cancel out this and make it 0 and cross multiply, so this side is going to be 0. So I have 0 is equal to M1 M2 G sine 30 degrees minus M2 Fa. So now let's take the force applied term on the left side. M2 Fa is equal to M1 M2 G sine 30 degrees. Now let's cancel out the two M2 terms, and Fa is equal to M1 G sine 30 degrees. So now let's plug it in. So Fa is equal to, the mass 1 is 3.0 kilograms, G is 9.8 times sine 30 degrees, and you get force applied is equal to 14.7 newtons. Which means if the force applied on M1 is 14.7 newtons, the cord will become slack and have zero tension. Awesome. Have a good day.